In this explainer, we're diving into one of the biggest challenges for AI today. Why does it hallucinate? It's a fundamental problem, especially for the large language models we're all using.
Okay, let's start with a classic example that really shows you the limits of AI. At first glance, this image looks totally fine, right? Just a pair of hands. But then you look closer and you start counting the fingers and you realize, wait a minute, something is seriously off here. This is the perfect visual for an AI hallucination, plausible on the surface, but fundamentally wrong underneath.
So, what are we actually talking about when we say AI hallucination? Well, it's basically when a model spits out information that sounds totally convincing, but it's either factually wrong or just made up, not based on any of the data it was trained on. And it's crucial to get this. The AI isn't lying. It's not trying to deceive you. This is just a natural consequence of how these systems work.
So here's how we're going to break this down. First, we'll look at the phenomenon itself. Then we'll get into why it happens, comparing it to something like a calculator versus dice. After that, we'll dig into the root causes, look at strategies people are using to fix it, and finally, tackle the big question. Is this a dilemma we can ever truly solve? All right, let's get right into that core principle. The whole reason hallucinations happen comes down to a really fundamental difference in how these AIs are built. You have to understand they don't think or work like a normal computer program. Think about it this way. A calculator is what we call a deterministic system. You put in 2 plus 2, it follows a set of hard-coded rules, and boom, you get 4. Every single time. An LLM, though, that's a probabilistic system. It's much more like a high-tech game of dice. It isn't calculating the one single correct answer. Instead, it's constantly betting on what the most likely next piece of the puzzle is, based on all the patterns it's learned.
And this, right here, is probably the most critical point to understand. These models are designed for one primary job: next word prediction. Their goal isn't to be truthful, it's to be plausible. They're built to create language that sounds natural and convincing. Whether or not that language happens to be factually accurate is almost a side effect. It's not the main objective. Okay, so if the whole system is built on probability and just predicting the next word, that leads us right to the root of the problem. Why does a system like this have such a tendency to just fabricate things? It really boils down to a perfect storm of 3 things. First, you've got the training data itself. It's messy. Second, there's the training process, which is all about spotting correlations, not understanding cause and effect. And third, and this is a big one, you have the way we test them. The very benchmarks we use actually encourage them to guess rather than admit they don't know. It's a systemic issue. Just think about what the training data is. It's basically a snapshot of the internet. And what's the internet? It's a huge, chaotic library filled with inaccuracies, outdated info, and all our human biases. The AI ingests all of it. So not only is it learning from flawed material, but sometimes the one tiny, correct fact it needs is like finding a needle in an unimaginably massive haystack of irrelevant data. This quote from a German parliament report really hits the nail on the head. It says the systems can't develop understanding in the human sense. And that's exactly it. The AI doesn't comprehend the answers it gives. It has no idea if they're right or wrong. It's just a master of pattern recognition, spitting back the most statistically likely sequence of words. And this leads to a really messed up incentive structure. Think of it like taking a multiple choice test, where there's no penalty for guessing. What's your best strategy? You guess on every single question you don't know, right? Because you might get lucky. Well, that's exactly how we're training these AIs. We punish them for saying, I don't know, but we reward them if their wild guess happens to be right. We're literally teaching them to be confident fabricators. And this chart just shows you the result of that bad incentive. You've got 2 models here. The guessing model gets a slightly higher accuracy score. We're talking just 24% versus 22%. A tiny, tiny improvement. But at what cost? Its error rate, the number of times it hallucinates, is a whopping 75%. That's nearly 3 times higher than the more cautious model. The system is literally optimizing for a model that's wrong more often. So, okay, the problem is baked into the system. It's not a simple bug. So what do we do about it? How can we actually start to get a handle on these hallucinations? Well, the good news is that researchers are tackling this from a bunch of different angles. It's not just one magic bullet. They're looking at everything from the core architecture of the models to the way we prompt them, all with the goal of making them more reliable. One of the most promising techniques is something called retrieval augmented generation, or RAG for short. The easiest way to think about RAG is that you're giving the AI an open book test. Instead of just trying to remember everything from its training, it has to go look up the answer in a specific, trusted knowledge base, like your company's internal documents. This forces it to ground its answers in actual verifiable facts, not just its own statistical guesswork. And RAG isn't the only tool in the toolbox. There's a whole suite of other approaches. For example, chain of thought prompting, where you make the AI show its work, step by step. That alone can boost accuracy. There's also using things like knowledge graphs, building better benchmarks that actually punish guessing. And of course, the ultimate backstop, having a human expert in the loop to verify the output. You just can't get away from that.
So with all these strategies, it begs the million-dollar question. Can we actually solve this problem for good? Or are hallucinations just something we're going to have to live with when it comes to this technology? This is where things get really interesting. You have experts like Carl Bergstrom who argue pretty forcefully that hallucinations aren't a bug at all. He says they're a feature, a direct result of how we've chosen to build these things. And from his perspective, just throwing more data or more computing power at the problem isn't going to fix it. We might need a whole new approach to AI research. So let's just bust a few myths here. First, hallucinations aren't some weird, mysterious glitch. We actually have a very good handle on the statistical reasons why they happen. Second, the idea that we'll just scale our way to 100% accuracy and make them disappear, that's a fantasy. 100% isn't going to happen. But that also doesn't mean they're inevitable. The real game changer isn't creating a model that knows everything. It's creating a model that knows its own limits. A model that can recognize when it's uncertain.
So, in the end, the challenge isn't about fixing a bug. It's about learning to manage an inherent characteristic of the technology. We probably won't ever get rid of hallucinations completely, because at their core, these systems are built to predict, not to know. The real work, the important work, is building systems around them that can manage that weakness, systems that can catch, control, and compensate for it. That's how we turn this powerful but flawed technology into a tool we can actually trust.